Let's go.
All right, I guess we are good to start. Hi, everyone. Welcome to our session on running stateful workloads on AKS. I'm Yueming. I'm joined on stage today by Francis. Both of us are PM from Azure Storage team. We work on container storage. Our goal is to optimize our storage portfolio and also integration with containers to enable stateful workloads to run best on Azure. So in this session, a lot of our contents are pivoted for Azure Kubernetes services, but they are also applicable for your self-hosted Kubernetes environments or other container options that you're using. So in the past years, we have definitely seen a growing adoption of Kubernetes for stateful workloads for production environments. Taking database as an example, the usage has tripled over the past years. And you can see a very similar pattern across different workload types. And Azure-wise, we have a wide range portfolio of products to support your workloads for different requirements, ranging from PostgreSQL, MongoDB, or Kafka, Cassandra, which are more performance sensitive, which you'll be using our block storage products, and then to the AI workflows like Kaido, Kuberei, and also analytics like Airflows, which are more looking for scalability and better throughput to deliver what is needed for your big data workloads. So from our perspective, we wanted to optimize not only the backend storage options, but also build integrations into the Kubernetes environments so that you'll be able to gain all these benefits of these storage offerings directly via Kubernetes native interfaces. This is where we not only adopted the industry practice, CSI drivers to build you different CSI drivers across the options. We took one step forward. We introduced Azure Container Storage, which is a unified Kubernetes native volume orchestrator, where we intend to build the optimization for you to use a storage for your stateful workloads in the Kubernetes environments in a more seamless manner. So having said all that, we do know running stateful workload is not so easy. If it's that simple, you will not be here listening to me and Francis. So to make this session more practical or useful for you all, we picked 4 representative workloads across 3 segments so that you will be able to you can hear from us what are the best practices and some of the effort that we put in to help you optimize these workloads and streamline the deployments on Azure. We will start with PostgreSQL, popular open source databases. Then we will go into AI. We'll have 2 examples. One is Kaido, the other one is Kuberei, on how you'll be able to deploy and accelerate your model file load time using these AI workflows. Last but not the least, we will cover GitHub Actions, which is one of the CI/CD workloads where many of you may be starting your first stateful workloads in kind of looking at automating your build pipeline. So that's where we will wrap up. All right, let's get into this. So PostgreSQL. So when you think about PostgreSQL and these type of database solutions, you'll need to make sure that, first of all, it is reliable, right? Like for Kubernetes-wise, you have pod movements, you have pod failures, you have pod moving from one node pool to the other and all that. You wanted to make sure that during these movements, your database continue to run seamlessly. You cannot afford, if this database is storing your e-commerce transaction logs, to go offline at any time of the day. So highly available architecture is very important. Second part is about operational standardization. This means that when you're deploying your production workload, you want it to minimize manual effort, right? You don't want it to deploy AKS cluster, then apply a few configurations. You need to log into your pod and do a bunch of things. So this is where you're looking for better to streamline the deployments to minimize potential risks that is introduced due to human errors. Lastly, as part of the journey for containerizing your applications, you're looking for cost savings, right? When you move the hosting from your VM setup into a Kubernetes setup, you expect to gain certain cost savings and TCO reductions as part of this. So from our perspective, the way we wanted to answer all these questions are in twofold. One area is that we are embracing and leveraging the open source community in adopting Kubernetes operators. How many of you knows about Kubernetes operators for applications? Great. I think it's probably one-fourth of the room. So this is an area where if you're not familiar with Kubernetes operator, so this is consider it as a custom controller that helps you to manage and package your application management deployments against Kubernetes. So there's a lot of open source Kubernetes operators which has been purposely built for targeted workloads. For example, in the cases of PostgreSQL, Azure-wise, we adopted the cloud-native PG operators for PostgreSQL, and we did the work to validate and automate the entire process as part of that. And we're looking into further making contributions to the operator community to optimize it for Azure. So by using the operator, we're able to streamline the deployment. And also what is best is that it comes in with best practices for setting up PostgreSQL. So as part of the Postgres operators, it by default has a HA setup that it uses a primary and two standbys that could help you to structure it in a very available and resilient manner. So those are the things that we leverage the community wisdom. Then there are parts which we focus on strengthening our Azure platform. Because with all these things, we still wanted to ensure the platform level is very well optimized for running stateful workloads. So in this case, monitoring always comes top. Like for databases workloads, you wanted to make sure that your performance aspects and all that are met. So we have Azure monitoring integration and also managed Grafana for you to look at very detailed metrics related to your Kubernetes clusters. On the perf and price perspective, for large databases workload, you cannot work around with block storage disks. Where are you going to store your database log files, your database data files? This is where that here we wanted to highlight two storage options for you. One is consider using local NVMe drive. This is something which we will later show you a demo on if you leverage local ephemeral drives, what is the scale limit you'll be able to push on AKS, PostgreSQL deployment on AKS. Besides that, you also have an option which is well balanced for price performance, which is leveraging our latest premium SSD V2 disks. And we will show you the performance and also the price points of these two options shortly. All right, I know for build, every one of you are here to watch demos and see how we could actually do things in a real production setup. But I wanted to still walk through exactly of what we will show you in the end. So we will be doing a deployment of a PostgreSQL cluster on AKS. I wanted to note that this is not a vanilla setup. Okay, one instance, you play around, you cannot really take it into production. So this is where we'll show you one primary setup and two standbys across 3 availability zones so that it is resilient for zonal failures. And then they also have the integration with backup, which is application level backup using blob storage. So all of this will be in this one script I'll be running just in a bit in deploying the entire setup. All right, so the exact demo flow will be 4 steps. One is that it will be provisioning the clusters. Then we will assign roles and configure access. Next, we will deploy the operators, which will deploy the PostgreSQL applications. And lastly, it's the entire setup, and we'll run a benchmark. So let me move to my demo machine. So here, I am going to run a very simple shell script. So this later we will share with you the link to this GitHub repo. So all of the demo we're sharing it today, you will be able to repro it right away. So we'll send with you all the links so that you can run it today on your Azure environment. So what it does is that it will first set up the resources as part of the creating all the related resources as part of this. It actually assigns the user identities as part of this, creating the storage account, what you need to store your backup informations, do the proper permission assignments, and create the AKS clusters. So We have speeded up so that you could see the entire workflow. Afterwards, it basically added your user nodes pools into AKS, and now it goes into creating a storage class. So I'm going to stop here a bit, as this probably is a step you may not be familiar with. So for folks who doesn't know about Azure Container Storage, this is a step in creating a storage class in Azure Container Storage to use your local ephemeral drives. So very similar as how you will create storage class if you're using disks or files. So as part of it, it will create the entire flow, and then start creating the IP addresses for Postgres clusters. As you can see, it's now deploying the PostgreSQL clusters, and then the last step of this entire script will be running a benchmark. So the entire automation is building in this one script that you'll be able to run, and then what it does in the end is that it actually conducts a benchmark run to validate that the database deployments are solid, and then you'll be able to see what is the performance that you're getting out of this PostgreSQL deployment. All right, now I am going to show you an actual benchmark that we actually ran against two setup on Azure, on AKS. So the specific setup we have here on one side, it is using the ephemeral disk, which is local NVMe drive. On the right side, we have it, which is using premium SSD, just as a baseline. So what this benchmark does is that it actually creates 64 clients, and each client have 1,000 queries that goes against this PostgreSQL database instance. And it will go and measure what is the transaction per second you will be able to achieve on both of these database instances, and also the latency. So it is intended to simulate a real life kind of transaction type of workload. Think of it as that you have, you have a database which you track on user transactions, like purchase records and stuff. So this is intended to showcase that. As you can see that on the right, on the left side, which is where the benchmark run finished very quickly, the latency is around 4.5 milliseconds. Just note that this is not I/O latency. This is actual database transaction latency. So it's kind of finishing this explicit database call. And then the actual transaction per second can go up to close to 11,000 per second. And if you compare to the right side, just kind of a reference, it is significantly higher as what you will be able to see by using local NVMe drives. So at this point, you'll be like, okay, local NVMe drive is cool. Then all cloud seems to have VMs that come with local NVMe drives. So what is it so special here, right? If you look at it, for NVMe drives, what we provide on Azure with AKS is that we give you a way to utilize your local NVMe drives using Kubernetes native APIs. So when you just deploy an AKS cluster, which comes with VMs with local NVMe drives, these drives will be surfaced as individual kind of drive letters. So how are you going to utilize them, right? How are you going to place your persistent volumes? Because none of you wanted to be in the business of manning raw block storage, right? What you want is that, oh, I just go to my kubectls and I deploy a persistent volumes. Whatever is the backend, you take care for me. And that's where with Azure Container Storage, we basically manage the different type of block storage for you, where on your end, you just need to learn and know about the kubectl commands on how do you create a persistent volume, and that's all. And as part of the work we did for local NVMe drives, we put tremendous effort in looking at from the data integrity aspects, because your NVMe drives could potentially have failures, right? How are you going to leverage it to give you the best performance out of all the drives that is out there? So these are all being taken care of by the Azure Container Storage, which is the platform managed orchestrator that we have. Beyond that, Azure Container Storage also supports different block storage type. So in the cases that you don't need local ephemeral drives, you're like, okay, I wanted to use disk or Elasticsearch. This is still the single orchestrator that you need to manage and install, and you can use any of the backing storage option of your choice. In that case, I do wanted to go back and talk about the performance and price aspects because, storage-wise, we have a wide range of offerings, right? When you look at it, a lot of the, your trade-off is between, okay, what is the performance I wanted to hit, and what is the lowest price point I'll be able to get the target performance? And this is a benchmark that we run it with PostgreSQL. On the left side is using Premium SSD v2. It provides very good cost efficiency because if you look at it, the setup that we show you, this is actually not the largest disk. It is a disk that costs you only $10 per month. It's able to give you very comparable performance in the cases that it can go to 8,000 transactions per second. And the latency is in the point that is very close to what you'll be able to get even from a local ephemeral drive. So for all of you, if you needed the most scalable PostgreSQL deployments, definitely go with local NVMe drives. But then when you're looking at, okay, I wanted to actually balance for my price point, I wanted to grow my PostgreSQL as my database scale, then Premium SSD v2 will be a great option as you'll be able to provision your capacity, IOPS, and bandwidth on the fly, and then scale as your need increase. All right. As I promised, all the demo we'll show you today, we have GitHub or documentation that is already available. So feel free to take a photo, and then you can also get access to the slide decks where you could try out all these demo setups. And we are having a lot more stateful workload documentation on our website besides PostgreSQL and what Francis will cover on some of the AI workflows. We have MongoDB, Kafka, and a wide list of the stateful workloads. And if there's any that you are looking to run and there's yet any guidance from us, don't hesitate to shoot us an email. All right. I am now going to pass to Francis to talk about AI.
Thanks, Jimmy. So, yeah, give some impression. Thanks, everyone. So I'm Francis. Today, I'm going to cover two type of workloads. One is AI, another is CI/CD. So we're trying to kind of give you the best how we can support these two type of workloads, especially for AI, to be successful with Azure. So first, we want to look at what kind of problems today, because we know AI wave is huge. Everyone's just trying to jump to this wave, but generally, all the customers have some general problems. If you look at all the problems, if you look at the longest bar, you can see top problem, first one is about high compute costs. I think it's reasonable because we know the GPU is expensive, GPU VM is expensive. So what's the best way to reduce the cost and get the maximum out of the GPU and the cost? Second piece is about lack of Kubernetes experts regarding the data. So because the great assets that you have put a lot of investment is data. You're trying to generate the model files to support your different type of agents. So how to make the best with the data? So we know traditionally Kubernetes is kind of service-oriented platform, but when you're trying to move to leverage that to scale your workloads to get the max value for AI, so data is something important. So first, we want to have some touch base with Cato. I'm not quite sure if we have some audience have heard about Cato. Anyone? Great,
okay,
more than I thought.
AKS fans.
Yeah, you are really AKS fans. So Cato is unified framework to kind of for scaling your AI workloads and Python applications. It also provides very rich runtime and libraries to accelerate your workloads. So sorry about that. So I just jumped to the next one. So Cato is operator to automate everything you need to run the tuning jobs and inferencing on the AKS and or Kubernetes. It's actually open source, as you know. In the same time, Cato is also managed add-on as part of AKS, who have a very seamless integration to provide the best out of Kubernetes platform on Azure. So Cato automate everything. It recommends the best option. What kind of best GPU VMs depends on your model type and model files. And also, it just prepare everything, manage the entire life cycle for your GPU node or even other general VMs. And it defines an ultimate way for you to kind of easily to set up your tuning or inferencing workloads automatically with Cato support. So as you know, one of the kind of pressing phenomenon is model files getting bigger and bigger over days. So traditionally, the original GPU VM general have some defined memory. For example, typical GPU VM have 40 gigabytes to 80 gigabytes memory, but model files today with DeepSeek V1 has been increased to more than 400 gigabytes. So in order to make the best from this kind of increased model files, so there's some pressing need to support distributed inferencing on top of model files. So Cato is going to support the distributed inferencing with Azure Container Storage. As we mentioned before, Azure Container Storage is the native way to provision your volumes out of local NVMe disk, give you best IOPS, best throughput, very low latency, and stable. That's kind of great advantage that can facilitate the AI workloads. So the idea is distributed referencing will shard the large model files and put each shard of the model files in each GPU VMs. All the model files will be cached on the local NVMe volume supported by Azure Container Storage. So in the latter page, you can see the great performance Azure Container Storage can get out of it. In general, if you know how to load the files, if you don't have a specific design, so in general, you are going to use host paths basically to load the files from remote object storage, which is great for cost efficiency, and also download to the local host path, which is local OS disk. In general, it would be local SSD. The protocol between CPU and memory will be SATA. So if you look at, if you are trying to load Llama 3.1 model files is around 120 gigabytes size, and it's taken like 270 seconds to complete load the entire files. But if we are using Azure Container Storage to place the cache layer, so it's just complete the loading within 50 seconds. It's almost 6 times faster, which means we get your most time with GPU to do your workloads for agents, etc. So that's kind of great performance offered by Azure Container Storage. We are using stripe volume, trying to parallelize your kind of read-write operations across available disk from the GPU VM, which is you already pay that. You don't need to have additional costs on that high performance storage option. And especially with Azure V5 and V6 generation VM, local NVMe disk will be generally applicable, will be supported. So I will kind of encourage everyone to have some learning to get the maximum from something you already paid, but you don't have a chance to get the most out of the local NVMe disk. So next we are going to talk about Cato, Kuberay. So let me ask you the question again. How many people know about Kuberay? Great.
Does people know about Anyscale? No? Okay.
Okay. So as probably I just misspoke before. So Ray is a unified framework. So basically to facilitate the scaling AI workloads, it supports not just the tuning, it supports the training, tuning, inferencing. So it's an open source project, which is very popular workloads, as we can see from the community, also on Azure. Kuberay is operator to manage the deployment, manage the Kubernetes resources for Ray. And today we are going to demonstrate how you can easily run the tuning, model tuning with Ray by the integrating with blob storage, get the most from the blob fields. So from this architecture, it's kind of very typical setup for the tuning. So you can have, depends your kind of the performance target, you can have 10 nodes or less or more. And you can run all the tuning jobs in the nodes, typically with GPU VMs. And you can use blob fields to connect your parts with remote storage accounts, blob storage accounts. So you can basically place any data required for the training, tuning, or inferencing. So for example, you can store the training data set in blob storage, and you can put checking points that produce during training or tuning in the container as well. And model files is definitely some great assets you want to have the maximum, let's say, value from that, and especially blob storage provide a kind of lifecycle management to reduce your cost over time further, and have the great releasing options, ZIS, GIS, GZIS, etc. So that's kind of mechanism how you can use blob storage to facilitate tuning with Ray. So as we mentioned some of the benefits already, so why running KubeArray on Azure? So first, we are adopting the KubeArray as a popular concept operator to manage the deployment and Kubernetes resource automatically for you. So you can save your effort and reduce the complexity. And traditionally, you need to kind of run the 10 steps or 100 steps to complete all the completions. High availability. So as we mentioned, so with blob storage, we have seamless integration, so it can offer the best availability through the data and on the data. We streamline everything that's required for the deployment and the configuration that you need with Terraform integration. So you can further streamline your process with typical CI/CD process. KubeArray also have the built-in monitoring mechanism, but you can also have easy integration with Prometheus and Grafana, which is something you can further custom your monitoring capabilities through performance, or let's say problems troubleshooting, etc. with that integration. High performance, as we mentioned, so you can have just like traditional PV configurations to plug remote blob storage and with your tuning jobs or training jobs. So we have the streaming model to support you get the best latency for the first byte. And also, all the operations can be parameterized, including both reads and writes. Last piece, probably you already see the great demo from Mark. So blob fields can offer the great throughput if you are dealing with large scale data. So based on the previous benchmark, you can achieve 8 Tbps ingress and around 14 Tbps egress, which is great. Good enough for your kind of handling 100 terabytes, or even petabytes files. So typically, KubeArray setup flow will include the 4 phases. First one is basically, as you know, you need a provision AK clusters and also any other Azure resources to support your workloads. Second piece probably is the most troublesome steps you don't want to do in general. Even for myself, I have spent a lot of time to do the troubleshooting in order to connect different resources together with different configurations, especially for access configuration, in order to make your kind of working load up running. So third phase will be deploy KubeArray as an operator to facilitate deployment and management as part of deployment. At the end, it will have dry run for the Ray job for image classification. So we are going to have a quick demo to see how we are going to do the tuning job with real integration with Ray experience. So at the very beginning, we already have the sample project in GitHub, so you can just clone the project locally and just run the deployment script. It already have the integration with Terraform already, so all the results will be configured in the template. You can just modify as you need it. We also integrate all the access configuration and other configurations required to get the tuning job up running. So at the end of the deployment is really fast if we are using the default configurations. So at the end of the deployment, you are going to have the dashboard to see what kind of working on the clusters, etc. So here is the dashboard. You can see the status regarding clusters or metrics, even your jobs. So this tuning demo is going to use ChatGPT GPT-2 large model files, and we are using 10 nodes to supporting these tuning jobs. So from here, you can see that all the required jobs and the nodes, they'll be up running for this tuning demo. From the built-in dashboard, you can also see the clusters and jobs information and the status. So this is a Python script that prepare everything we need for typical tuning. And we are using GPT-2 large, and also in order to have the efficient demo, we reduce the epoch 2. So this is the story count. As we mentioned, it is used in the tuning. It's used to store both the training data set, model files, and also checking point files. So here we start the tuning jobs. The job has been started. We can also see the job status in the dashboard. Here's the story count that is used to place the checking points and model files, as we mentioned. These are all produced during the tuning cycles. So as we mentioned, we are using CSI blob drivers to connect and position the PV and connect with the blob containers remotely with blob physics protocol. So it's already, as part of AKS clusters, you can just enable it. So here we are going to show you the story class YAML files with the typical concept whenever you're using a story option. So it's basically the same experience, but just with different configuration. So you can just plug the blob container easily. It's just a configuration. You can specify the mounting options. In this story class, you can see we are using manager identity to ensure the authentication between blob story count and also your tuning jobs. And we are using blob fuse as protocol for the communication. With defined storage class, so next you just need to create YAML files for your PV and PVC. So you can specify which kind of volume you're trying to store the checking points or result files or training data set. Here is a typical rig class configuration files. For your jobs, you just specify the volume you just configured as a part of the rig job description. So you can also log into the pods to see what has been produced and written to the remote blob storage account through the local PV. So at the end of the tuning jobs, so you can also use a rich metrics offered from storage account to monitor and manage the traffic that has been occurring during your tuning jobs. So here you can see use the ingress, egress metrics, also the transactions happening on storage accounts. So you can have good understanding and management on the network traffic. So that's the end of the demo. So we talked about a lot regarding the demo. So yeah, don't worry about anything complicated. You just go to our sample project, get all the scripts already published as a part of the documentation. Yeah, you can run it today if you want, and if you have GPUs. So the last piece, I'm going to have some discussion regarding CI/CD with GitHub Actions. What we recommend you to use as part of CI/CD workloads or GitHub Actions. So as we mentioned, CI/CD is a kind of popular, I would say, service or fundamental components that you need today to modernize your application, because it typically required for any organization. Everyone wants to streamline your process from code changes to build, to test and validation, until the deployment to your production environment. So CI/CD typically addresses these kind of cycles and needs end-to-end. With GitHub Actions, so we have the GitHub Arc to monitor the changes on GitHub. So you can define to monitor the changes and kick off the entire workflow as you need it. And your workflow basically can cover everything I just mentioned. Have the build for your changes, validate your changes, and have safe deployment from staging environments, or test environments, staging environment to production environments. Typically for CI/CD, all these workflows will require shared accesses across different phases. So in general, most people will consider the files, because this CI/CD will have very heavy file operations, also requires shared access across different phases. So for Azure, you can consider Azure files or Azure Network Files, because both provide this kind of capability for you. So as we mentioned, some brief already. So GitHub Arc already have the capabilities there. So today you can just easily leverage that to kick off your CI/CD process as you need it. We mentioned two options on top of Azure, but we recommend you to consider Azure Files because of the optimal cost of performance. It has low cost relatively and have good performance. Especially we have recent improvements to support the metadata caching. As we mentioned, CI/CD typically are files operation heavy workloads, basically. So with what I mentioned, metadata caching is improving your performance in dealing with like a file rename, file operations, etc. With these improvements, it also will reduce the latency for your file operations and improve the IOPS. So this just get your maximum from the network throughput. So we already provide the demo, but unfortunately we don't have enough time to show the entire demo. But again, just take the barcode and you can reference offline. It has very detailed introduction. We have samples as well to help you to do a similar work when you have time. So that will be end of my session. I will pass back to Yuming.
Perfect. All right. Okay. So I know we don't have build breakout sessions are very, very hard sessions to get. So we wanted to make sure that you all get the best out of the session. So we have compiled the recent updates and upcoming roadmap across all storage portfolios. So everything that Azure Storage will be providing. And then it is a very long list. So I will be touch upon a few which are more relevant in the stateful containers workloads kind of settings. But feel free to take a photo for any of this. So from a block storage perspective, I wanted to kind of highlight 2 areas. One is about Azure Container Storage. We just demoed about Azure Container Storage in both the Kaido and the Postgres scenarios. We're continuing making enhancements on that so that first of all, the installation path will be even simpler than today. I think right now with our Arc extension, some of you who are not very familiar with Arc extension, you could be tripping off there. So we're improving there. Second is about the resource allocation. So Azure Container Storage does, is installed in your AKS cluster. So in optimizing the local storage performance, it does incur some resource consumption. So we're going to drastically reduce that in this next version. Great. I think hopefully that's good news. It seems like you probably have tried it out. So that's an area that we did hear feedback. We want the resource consumption to be more dynamic and then minimizing the initial footprints and all that. And we'll also support, GA of Elasticsearch as part of this. The other area we wanted to highlight is on Premium SSD v2. So today, if you use this CSI driver, you can use Premium SSD v2 today, but then you need to create your own storage classes. This is where we will be building and creating a class for you so that it will be easier for you to use Premium SSD v2. Along with that, we are going to also add supports on v1 to v2 upgrade. This is one thing we have already built and is waiting for some upstream changes to come in so that for customers, for everyone, you are already using Premium SSD today and then you're impressed by the Premium SSD v2 performance and also the cost efficiency that comes with that. Very soon, we will have it building in the CSI driver so that all you need is to set a PV level attribute to move it from v1 to v2. So you yourself doesn't need to do this full orchestration. All right. Then if I move to Blob and also data lake storage, Blob Fuse 2, I think many of you have seen the demo, and then I think storage has an AI session, which we also talked about using Blob Fuse for AI. So as part of Blob Fuse 2, I'm going to just highlight the new preview features that have come out, which is on the data preload and mount time. This is where that when you actually mount your storage account, you will be able to specify prefix to actually preload a set of data so that it's able to stream it to your local node and accelerate your download and access speed for your Blob account. Then there is Azure Storage Connector for PyTorch. So for anyone who is AI developer or wanted to be AI developer, this is a new client library support that we have to help you integrate in using PyTorch development for using PyTorch and then use data in blob storage for your development. For coming soon, it's storage discovery. So this is somewhere if you have a large set of storage assets that you need to manage, this is where with storage discovery, we wanted to build you kind of a single plane of gas for you to manage and also monitor your storage resources. So there is a QR code for sign up for early preview here. All right, let's move to talk about files. So from files, one of the key enhancements we recently made is definitely on the metadata caching improvement. So like for instance mentioned just now, it's where when you have persistent volumes that is on a share and then you have multiple files in that, for operations like for workloads like CI/CD and also even with WordPress, you have a lot of small files. So your operations are against a lot of file operations against small little files that you have it on one share. And this is where traditionally you may be running into some of the limitations on the share level metadata operations. You're trying to open and close your files. But without enhancements on the metadata caching, you will be able to see a significant improvements on these areas. I think it's like 2x or even higher, depends on your use case. And this is something that you don't need to do anything on yourself. That is something on the file side. We are enabling this metadata caching for you instead of some caching enablements that you need to manage. The other area I wanted to touch on, this is one of the most wanted feature we hear from is on Azure backup support for AKS when you use files as your shared PV. So typically by default, if you want to have read-write many or read-only many type of PV, you get into files. But then as you're using Azure Backup for your AKS backup, these persistent volumes are not included in your backup. So that's kind of a problematic for you if you're really looking into backing up your cluster. So this is something which we right now are in public preview for your SMB share, and we are actively working on extending it to NFS share. So it is on our roadmap. We are actively working on this. Then let me talk about Azure NetApp file. So from Azure NetApp file perspective, this is where you have higher performance requirements related on your persistent volume, and this is where you'll start looking at Azure NetApp files. And from Azure NetApp files perspective, we also collaborate with NetApp to make a lot of enhancements on this area, particularly on reducing the initial footprint on your Azure NetApp file deployment. This is where we hear quite a lot on, oh, my initial kind of PV needs to be very large, and that is very costly. So right now, the PV sizes for the minimum volume is now reduced to 50 GB. I know they're asked of even moving it to smaller GB sizes. This is something which we are working on, and right now I think we have already made improvements to bring it down to 50 GB on the volume size. And along with this line, a lot of the enhancements on Azure NetApp files is on the capabilities that will help you to reduce your price performance, right? There is the flexible service levels and different kind of knobs that we now offer on Azure NetApp files, so that you'll be able to more effectively control your cost and then provision what is needed at your performance level. Right. So that covers most of the, all the roadmap, all the key products. And then we have here, I just wanted to flash it on our Azure Storage Mover. This is a new preview program we have started on helping you on migration. So if any of you or your organization have the need to migrate data from AWS to Azure, try out Azure, Storage Mover. This is a free managed services that we have now in preview. So it supports AWS S3 migration to Azure Migrate. So you can scan the barcode for access to this preview. Last but not the least, I wanted to echo back on our focus on helping you all in running stateful workloads on Azure. So we definitely have taken a different approach than before. This is one of the things that over the past 6 months, you probably have seen both storage team and also AKS team have putting a lot of effort in workload guidance, right? This is an area we understand that, yes, we have a rich range of products, but then we left it to you all in choosing, oh, which product should I use? What is a combination I need to go with? So the product team has taken the responsibility to look at hero workloads like Postgres, like MongoDB, like Kafka, Cassandra, that we look at what is the open source operator. We run it on Azure. We run it on AKS, choose the storage option for you, and then we publish it in our documentation. This is a site that goes there. I think this is the GitHub site, but then we also have the Azure documentation that tells you how to run all these stateful workloads with the optimal settings on Azure on AKS. And then we're going to take it further. Some of these workloads already have automations. For example, the Postgres one, we have automation with shell script. And then I think Kafka, we are already building Terraform integration. So we're looking into building more streamlined approach and automation so that you will be able to deploy the workload on Azure AKS without needing to think about how I need to pick and choose between all of that. And if there's any suggestions or any areas we could do better or workloads you wanted us to focus more as part of our future optimizations, don't hesitate to send us an email at askcontainerstorage@microsoft.com. So thanks a lot for coming to this session. I know all the sessions are cutting very close, so we left 10 minutes at the end for any questions you have. So if you have any questions, feel free to proceed to the mic at the front and ask us. It could be about storage, container. We actually have a good set of storage PM here to address any questions you have. Well, if you're shy, you don't want to use mic, we'll be around. You could also ask us privately if it's very specific questions. Come on.